let's say there is a linked list where 1 points to 2, points to 3, 4, 5, 6, 7, and let's say 8, 9, 10, and let's say then this 10 points to 5. So now you can understand why I have drawn this linked list in this way, because one of the nodes is pointing to the previous node. So this is what my linked list is, and here is my head. If I try to traverse this linked list, can somebody tell me what will happen? That loop of traversal or recursion of traversal will end up running infinitely. Why it will happen? Because while you are on your way to traverse, so first you are here, you print 1, then you print 2, then 3, then 4, and then so on, 5, 6, 7, 8, 9, 10. Now stop here. The moment you are at 10, if you do 10 arrow next, you will come to 5. And then again this entire thing from here to here will pop up over here. So this thing will keep coming again and again. So this cycle thing will keep coming on and on and on and on and on forever. So the question is very simple. Question says that you have been given a linked list. Whenever I say given a linked list, what do I technically mean? The technical meaning of this is you have the pointer to the head of that linked list. Yes, you have the pointer to the head of that linked list. So let's say you have head of the linked list, and now you have to detect whether or not there is a loop. You have to detect whether or not there is a loop. If there is a loop, you have to return true, and if there is not a loop, you have to obviously return false. So listen my approach. The moment something got repeated, I said that hey, the reason this is repeated is because after this I would have got a node which is pointing to this. That is the reason it has got repeated here, right? So can I use a map of integer comma something, let's call it bool, okay? And while I am traversing, I am just inserting the integers in the map. So I inserted 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10. And after 10, it was 5, and this integer 5 was present in the map. So I said that hey, there must be a loop. What if duplicates are there? Very good. So if duplicates are there, this will never make sense, right? Because the case could have been that you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then again you have 5. So here this 5 coming over again does not mean that there is a loop in this linked list. So it won't work in case where the values are duplicate. So when would you want to say that there is a loop or not? Would you want to have a map with respect to value or with respect to node star, which is your address? Because if address gets repeated, then I am very, very sure that hey, this node is pointing to an address that I had earlier seen. So there must be a loop. And guys, this is a very, very important concept. You will see that while you learn graphs, in graphs when you are trying to detect cycle, something like this comes in handy, where you see that you are able to go back to a node which you had already seen while traversing the graph. It means that, you know, there must have been some kind of cycle. So that is the entire idea, that you are seeing the node which you had already seen, and it's node that you are seeing again. It's not the value, because the values can be repeated also, different values across different nodes. So I can just have a map of these things, and I'll simply be able to detect it, and that's how my job gets done. How many of you can implement this approach? Which kind of map will you have? The key of the map will be node star. Okay. So in case of something like C++, you would want to have an ordered map rather than unordered map. If you are using Java, you can definitely have a hash map. Can somebody tell me the time complexity of this approach? How much time did I take over here? Let's say there are n nodes. What is the total time? If you are using a tree map, then search or insert anything in a tree map, which is your ordered map, is of log n, right? So in that case, it will become n log n. But if you are using your own hash function, or if you are using a hash map which supports order 1 insertion and order 1 map operations, then it will be order n time complexity. Why order n time complexity? Because before you meet this node, you have to see all the nodes, and the moment you have seen all the nodes, you will automatically see this node, right? So this will be your time complexity. And what will be space complexity? Because your map will contain n records, right? Because if there are n nodes, all of them will be having different addresses. So the space complexity will be order of n. Now the question is that, can I do it in order 1 space? So what some of your friends are trying to say is something like this. Let's say there is a linked list like this, and then there is a cycle, okay? So somebody is saying that, hey, I'll have a fast pointer and a slow pointer, and my slow pointer will every time move by 1 unit, and fast pointer will move by 2 units. Eventually what will happen, that fast pointer will first enter this loop, which is this circle, because it is moving at a fast rate, and then it will keep on moving in this loop, fast pointer. And then after some time, slow pointer will also move in the same loop. And then, because there is a relative speed in between them. What is the meaning of relative speed? That the speed of one of the pointers is different from the other pointers. So definitely at some point of time, they will eventually meet. So guys, the idea is that there is this circle. See, forget this entire thing. Let's say there is a park, okay? Let's say there is a park, which is like this. And then there are 2 friends, friend 1, friend 2. Tell me one thing, just answer me one thing. There is some initial separation in between them. Let's say this distance is d, so initial separation is 2d. If this guy is moving with a speed of s, and this guy is also moving with a speed of s, will they ever meet? They will never meet. Why they will never meet? Because what is their relative speed? I am not talking about velocity, because velocity is a vector quantity, it has a direction also. Their relative speed is 0. So the distance in between them is never going to change. The distance will be constant throughout the end of the universe also. So here what you guys have told is that, hey, why not introduce some relative speed? Because now there is some relative speed, right? The speed of this is 1 and the speed of this is 2. So the relative speed is of 1 unit. So since there is a relative speed, today or tomorrow they will meet. I don't know when they will meet, but today or tomorrow they will definitely meet. I have seen it make sense to a lot of people, but actually it doesn't make sense. Okay, because this is just like, a wild guess. So let me ask you one simple question over here. Okay, forget about this circle and everything. Okay, just don't talk about these things. Now this is here it gets interesting, really interesting. Let's say there is a straight line, okay, and there are 2 friends here, friend 1, friend 2. Both of them are moving in the same direction, okay? Just keep looking here, okay? This is the most important part of this question. Friend 2 is moving at speed u, and friend 1 is moving at speed v. If v is greater than u, is it guaranteed that f1 will meet f2 at some point of time? It is guaranteed, and it makes a lot of sense. Now let me change this question. Here they were running, right? Here they were running on an infinite ground, right? But now I am going to say that, hey, let's say there is no ground. Let's say you have something like this. So there are certain obstacle points, okay? Obstacle point 1, obstacle point 2, obstacle point 3, 4, 5, 6, 7, 8, 9, 10, 11. And here you are jumping. You are not running, you are not covering this area, you are jumping from here to here, jumping from here to here, here to here, here to here, here to here, right? Now let's say there is a friend standing over here and another friend standing over here, okay? The speed of this is v, the speed of this is u. If v is greater than u, and if they are jumping, is it guaranteed that they will meet? Yes, so the right answer is, it is not guaranteed. Why it is not guaranteed? Let us say v is equal to 5 and u is equal to 1. So if v is equal to 5 and u is equal to 1, in the next time this guy will be here, but this guy will be 1, 2, 3, 4, 5. This guy will be here. And now because this guy with speed v is here and guy with speed u is here and v was greater than u, will they ever meet? They will never meet. So what actually happened over here? The thing that actually happened over here was that before they could meet, this guy overtook this guy. Before they could meet, this guy overtook this guy. Now, don't you think the same thing can happen in this round and round, this merry-go-round also, right? That they are about to meet, but the guy who is at the back has a higher speed and it overtakes. And it happens every time and it keeps on happening with some periodicity. And because of that, whenever they are about to meet, there is an overtake that happens. Again, whenever they are about to meet, there is an overtake that happens. But it's also not guaranteed that they will never meet. Okay, but I am not saying that I don't have to solve problem for that case. The moment you said that fast pointer and slow pointer will solve this question, you basically said that, hey, they will always meet. I am just giving an argument that it is not necessary that they will meet. It is not necessary that they will meet. For certain kind of value of v, u and initial separation. Initial separation is very, very important. For certain value of v, u and initial separation, it might so happen that they never meet. Yeah, now let's understand few more things. Here, which guy enters the loop first? Tell me, F or S? Which guy enters the loop first? It is F that enters the loop first, right? And then S enters the loop. When S enters the loop, would I know where F is? Would I know? I would not know, right? It would depend on a lot of things. It would depend upon how long this was, and it would also depend upon how long this was, right? So when S and F both are in the loop, what is their initial separation? That I do not know. Okay, and because initial separations can be different, sometimes they can meet and sometimes they cannot meet. But let us understand one thing. This thing, which is v minus u, it has a name called as relative speed, right? Does everyone understand the physical significance of relative speed? So let's say there are two guys, their separation is 10. He is moving at 3 km per hour and he is moving at 5 km per hour. This is all that you know. Can you tell me after how many hours they'll meet? This is 10 km. First guy is moving at 5 km per hour and second guy is moving at 3 km per hour. And the separation is 10 km. So after how much time will they meet? They'll meet after 5 hours, right? Why after 5 hours? Because 10 upon velocity of this with respect to this. And that is 5 minus 3. So 10 upon 2 is 5. So what is this 2? The relative speed is the rate of change of separation. Relative speed is the rate of change of separation. Because let's say initially this guy is at x and this guy is at y. Okay? And let's say y minus x is 10. Now what will happen that this guy will be at x plus 5 and this guy will be at y plus 3. Now if I subtract this from this, I'll get y minus x minus 2. So do you see that this thing is being decremented by the amount which is equal to relative speed? So relative speed is the amount by which separation gets reduced in every unit of time. And now tell me, whenever it so happens in this case that relative speed is a factor of initial separation d, can I say they will always meet? If the relative speed is a factor of initial separation, will they always meet? Yes or no? The answer is yes, they will always meet. Because let's say the initial separation was 10 between two of them, between the two friends, the initial separation was 10. And if this guy is moving with 5 and this guy is moving with 3, this 10 will become 8, then it will become 6, then 4, then 2, then 0. The moment it becomes 0, they will definitely meet. On the other hand, what if this was the case? If this was the case, then at t equals to 0, the initial separation was 10. And can you tell me what will be separation at next value of t, which is t dash? The separation is reducing by 3 units every time. So what will be the separation after this? Can somebody quickly type it? It will be 7, right? And at next time it will be 4. At next time it will be 1. And at next time it will be -2. -2 means that this guy will overtake that guy by 2 units without actually touching that. So this is just simple pure physics over here. Now tell me one thing. What should this thing be so that this is always a factor of this? What should this thing be so that this is always a factor of this? Which natural number is a... No, multiple of d cannot be a factor of d, right? Which natural number is a factor of every other natural number? 1, right? So if this relative velocity is 1, then no matter what is the value of d, always they will meet. Because if it was 10, it will become 9, then 8, then 7, and then eventually 0. You should be good with this kind of explanation when this question comes up, right? And here if you take a look, what is the relative speed? It is 1, right? And because the relative speed is 1, it is guaranteed that they will meet, because the moment s enters here, no matter what is the initial separation, the separation will always be reduced by 1 unit and they will meet. Okay, wait, does that mean that if I move my slow by 3 units every time and fast by 4 units every time, if I do this thing, will they still meet? Yes or no? Will they still meet? Yes, the same argument holds here also, because it's not about their independent speeds. It's just about their relative speed, because the rate of change of separation is proportional to their relative speed. So if the relative speed is a factor of initial separation, then they will always meet. And because I do not know what that initial separation will be, I will always prefer a relative speed of 1 unit. Now you might wonder that why do I always solve this question with 1 speed for this and 2 speed of this instead of 3 and 4? So that is because of cleanliness of our code. Because if you change this pointer by 3 units and this pointer by 4 units, you will have many null checks in your code to handle, right? So instead of doing that, you can do this. But from functional perspective, all that you have to ensure is that the relative speed is 1, and that will ensure that they will always meet. Can explain it in interviews. What has happened that some of the interview questions keep becoming polluted over the time, because all of the people have read it, they are all over on the internet. So interviewers, in fact, one of the guys who I know was asked this question specifically, and I think he knew the solution, but unfortunately he could not explain it. So you have to be good at that. Question, just ask whys, then you will automatically become good at that, right? Do not accept anything just like that. Okay, anyways, time complexity. So for every test case they will meet. Yeah, why won't they meet? Just proved it here for you. Because what did I say? First fast pointer will enter this circle. See, once both of them enter this circle, forget about this entire part. When both of them are in this circle, it's guaranteed that they will have some initial separation. Either they have already met or they have some initial separation. Now if the relative velocity is of 1 unit, definitely they will coincide at some point of time. Okay. Time complexity. Can somebody talk about the time complexity here? So I know all of you would have read that it is order n everywhere, but can somebody prove it to me? Why will it be order n? Okay, it's an easy one. Let's say this is the case. Okay. This entire thing is of size n. There are n nodes. If let's say this length is m, let's say this length is m, 1, 2, 3, 4, 5, 6, 7, m is equal to 7. Can you tell me after how many iterations slow pointer will reach here? After how many iterations slow pointer will reach here? It will reach here after m iterations, right? And is it a common sense that m is smaller than n? It's a common sense, I think, right? Okay. Another thing that I want you guys to answer is, when slow pointer comes over here, and no matter where my fast pointer is, whether it is here or here or here, no matter where it is, the separation between them if let's say that separation is m dash, that m dash will also be smaller than n. Now what is the relative speed? What is the relative speed? The relative speed is of 1 unit, and if the separation between the pointers is m dash and the relative speed is 1, after how much time will they meet? Can I say they will meet after m dash time? Yes or no? Yes. And because this m is also of order n and m dash is also of order n, so I can say that hey, approximately after order n time, both of them will meet. So the entire idea over here was that the moment both of them are trapped in the loop, it will at max take n more iterations. Sorry, it will at max take the size of this. If the size of this is m dash, it will at max take the order of size iterations for them to coincide. Let us do another question now. It is exactly based on this thing, but let's understand. If let's say this is my linked list and two pointers eventually meet somewhere, can't we just make changes in the struct to store some extra info like flag? What do you mean by that? I mean, yeah, you can do that, but if you change the struct, okay, let me take this question. If you change the struct, you already had a data part, you already had a pointer part, and now you have one more thing called as bool flag, which says whether you have seen this thing already or not. Now, don't you think that the extra space of this will be order n? Because this flag thing will now come at the level of every node. So initially every node just had 2 compartments. Now you have introduced 3 compartments. So tampering with the structure is actually, increasing your space complexity. So this is nothing which is a lot different from that map based approach. Sagar is asking, what if loop is greater than m, that is m? How does it make sense? Sorry. I mean, how does it affect anything? Even if this is very small and loop is very large, I do not worry, right? Because whatever will be the size of loop, that will be smaller than n, right? So when you code it, you are moving slow pointer by 1 unit and fast pointer by 2 units. So you have to have null check safety over here. And also the linked list that you will be given, it is not necessary that it will have a loop. You have to detect whether it has a loop or not. So you should have a condition that the moment your fast becomes null or fast next becomes null, you should immediately break out and say that, hey, there is no loop. Because certain times you assume that there is a loop and you keep making those changes without, checking something out, right? Only if you are, so I hope that makes sense to everyone, right? So you need to have this condition while fast is not null and fast next is not null, okay? And then only you keep checking, and then you have a check over here. If slow and fast have become equal, return true. Otherwise, you change your slow, you change your fast. This is how your algorithm is going to run. I hope all of you understand why I have this condition, because the linked list given to me might not actually have a loop. In that case, either my fast or fast next will become null and I need to break out of the loop. This loop, not that loop.